Good morning, everyone. I'm Ahmad MAAN from Curtin Group 11. Today in this presentation, we are going to discuss about a substitute for cement-based concrete. Our group members are Fernando UKS, Ahmad MAAN, Silva GNL, and D Silva SKA. Introduction: Concrete is a versatile material for modern construction which is prepared by mixing together well-proportioned quantities of cement, sand, crushed rock, and water. It has been used from foundations to the rooftops of the buildings. In this project, we are going to analyze the defect of cement-based concrete and discover a better sustainable method to make concrete. Next, the ingredients. We have categorized the raw materials as renewable and non-renewable, in which cement, fine aggregate, coarse aggregate falls into non-renewable category, while the water and air comes under the category of renewable raw materials. Next, we are going to discuss about the properties of concrete in this slide. Concrete is very high in compressive strength but has a low tensile strength. Concretes are durable, which will last for a long period of time, and also it is resistant to fire and other climate changes. Concrete has a capability to adhere or stick to a surface, which is known as adhesion. Some other few properties of concretes are flexural strength, shear strength, workability, impermeability, and elasticity. Next, Silva GNL will continue the presentation. Thank you.
Thank you, Nuski. I'm Silva GNL, and this slide is about how cement-based concrete is made. Concrete making process can be divided into several parts. The first part is the production of Portland cement. Next comes the mixing part. The cement is mixed with sand, crushed stones, admixtures, and water. Aggregates are pre-blended or added to the ready-mix concrete plant. Mixing operation uses rotation or stirring to coat the surface of the aggregate with cement paste and to blend the other ingredients uniformly. We can do this mixing part using manpower also. When the concrete mixture is ready, it is transported to the working sites. There are several methods of transporting, including wheelbarrows, buckets, pumping lines, and special trucks. Once at the site, the concrete must be placed and compacted. These two operations are performed almost simultaneously. Once it is placed and compacted, the concrete must be cured before it is finished to make sure that it doesn't dry too quickly. And finally, we have to pour the concrete and water the concrete for the first 7 days. And the next slide is about the uses and applications of concrete. Residential buildings, commercial buildings, roads or driveways, culverts and shores, foundations, lean concrete. What is lean concrete? The main function of it is to provide the uniform surface to the foundation concrete and prevent the direct contact of foundation concrete from soil. Bridges, marine constructions, and concrete dams. Those are the main uses and applications of concrete. And the next slide is about problems with the product. Problems with the concrete can be divided into 3 stages, including extraction of raw materials, manufacturing period, and disposal stage. Each stage can be categorized into several parts, and they are environmental, social, and economical problems. Since I have limited time, I'm not going to speak about all those problems. But as an example, when it comes to environmental problems and the extraction of raw materials, higher consumption of non-renewable raw materials is a major problem. And social problems and the manufacturing period, exposure to cement dust can irritate human eyes, nose, and throat. And again, social problems and the disposal stage, skin cancers can often be a disease for those who works or lives around concrete disposal places. And those are the main problems with this product. And the next slide is about the available alternatives in the market or in the construction field for concrete. First one, fly ash. It is a fine powder and it is a byproduct of burning pulverized coal in electric generation power plants. Blast furnace slag and that is the project we are doing about. For further information about blast furnace slag will remain in the upcoming slides. So the next one is microsilica and ground granulated blast furnace slag and timbercrete. What is timbercrete? Timbercrete, timbercrete is a blend of sawmill waste, cement, sand, and binders. So I would like to hand over the mic to Kevin.
Thank you, Nami. I'm De Silva, SKA. The reason for studying about the raw materials, users, and the problems of this product, existing product, is to find a better alternative. And the alternative we choose is blast furnace slag. And you may ask, what is blast furnace slag? It is the byproduct we get when iron is melted in a blast furnace. The reason for choosing this blast furnace slag is because it shows the same properties as cement. You know, nowadays concrete has become the second most used product in the world. So concrete consumes a lot of non-renewable raw materials. And if we don't find a better alternative, by like 2050, all the resources, natural resources will be depleted and the future generation will face a huge problem. So the main targeted problem of this project is to find an alternative which minimizes this extraction of non-renewable raw materials. There are many benefits achieved by using blast furnace slag in concrete. One of them is the ultimate strength gain is higher, less honeycombs, increased workability. You can see that when you perform the slump test, low bleeding in concrete. That means you may not find a layer of water on top of the laid concrete. Greater durability and reduced permeability, low generation of heat of hydration. It will prevent thermal cracking. Favorable color is obtained. The production cost is very low compared to OPC. That means there will be not that much cost for extraction of raw materials. So choosing blast furnace slag eliminate this threat of extraction of non-renewable resources. But it is not sufficient enough to say that the product made using blast furnace slag is equal in performance to the original product. So we have to do some experiments. So the test results of an experiment already done in China, I have shown here. That from the results of the table, it is said that the ultimate strength gain is equal or higher than that of normal concrete. So these are the test results of another test done in India. It also shows that blast furnace slag is equal in performance to the original product. And in this graph, you can see the carbon dioxide emission of concrete. And you can see the carbon dioxide emission of concrete made using blast furnace slag is lower than that of concrete made using ordinary Portland cement. So all of this shows that using blast furnace slag as a substitute for cement in concrete is better and is equal in performance to the original product. And now Kavesh will be concluding this presentation. Thank you very much.
Thank you, Kevin. I am Fernand UKS. I would like to talk about conclusion. When we use concrete and blast furnace slag as a combination, it would be much eco-friendly. The demand of aggregates will be increasing rapidly. If the concrete mixed with blast furnace slag, it would not cause any harm for natural inherent properties. Next slide is about reference. We found information about properties of blast furnace slag cement concrete from Bernard Azul and KG Haskar. We got brief idea about substitute for cement-based concrete from greensep.com. We understand now that when the concrete scraps are discarded, it has a bad effect to the environment. I would like to finish this presentation. Thank you for watching.